I've changed the numbers a bit, but this is just like your applied problem for this week. We're placing a ladder against a wall, and they're saying that it needs to be placed at a 75-degree angle so that we're roughly getting the 1 in 4 rule. 75-degree angle with the ground here. So this is my ladder going diagonal. This is the wall of the building. Then we've got a right triangle, assuming it's not my house, and it actually makes a right angle. My house is pretty old, so it's tilting a bit. You need to reach 11 feet up the side of the house, so we need this height to be 11. What size ladder do we need? So we need to know the hypotenuse of the triangle. So with the information we're given, we have an angle, we have its opposite side, and we want something to do with the hypotenuse. Opposite and hypotenuse lends itself to the sine function. Remember, we always put the angle inside the argument of the sine function. So sine of 75 should be equal to the opposite over the hypotenuse. So to figure out what the hypotenuse is, it's in the bottom of a fraction. The first thing we're going to do is multiply that h to both sides. And I'm going to divide that sine 75 from both sides. So we get h is, my handy dandy calculator. I'm going to figure out what sine of 75 is first with this calculator. I'm going to copy that and then do 11 divide by. So I've got 11.388. So we need a ladder that's 11.4 feet. In reality, we'd probably just look at a store and say, okay, I need something at least 12 feet or more, right? But for math class, that's what you'd want for your answer for part 1. Okay, but don't copy down that answer because it's not the same question. Part 2, they're playing a game of pool. They're bouncing a cue ball off the side. So pool is a game with a rectangular table, right angles all over the place. They're going to bounce the cue ball off the side of the pool at a 90-degree angle. So here's the path of my ball to strike the 8 ball. They estimate that a straight distance between the cue ball and the 8 ball. So here's my 8 ball, because they said they're going to bounce the cue ball, which is this open circle, at a right angle. Probably I'd have to put the cue ball somewhere else to make it actually be a right angle, but we're assuming it's going to make a right angle like that. Okay, cue ball, and it says the straight distance between the cue ball and the 8 ball is 2 feet. Maybe they took out that pool stick and they knew something about the pool stick to help them measure. They estimate the distance from the cue ball to the striking point of the wall. So this distance right here is 1 foot. How many feet is it from the striking point of the wall to the 8 ball? So we need to know what this is. And so this one doesn't involve right angle trig. We don't have an angle other than the right angle. This one would be the Pythagorean theorem, that a squared plus b squared equals c squared. And so to solve for x, we'd subtract that 1 from both sides. Oops, went ahead of myself there. So 4 minus 1 makes 3. And then take a square root of both sides, and we'll ignore the negative possibility. Normally, when you use a square root to cancel out a squared, we plus or minus our answer. But this is just going to be positive square root of 3 for our answer for part 2. Part 3 of 4 is just trying to estimate the height of a tree. So here's my tree. The forester is standing, so he's tilting his head. So the forester is somewhere away from the tree, and he's tilting his head up at a 75-degree angle. But look how I'm drawing it a little higher, because we've got to take into account the height of the forester. So this angle of elevation is 75 degrees. And then he's standing 60 feet away from the base. So this is a 60-foot distance. They make a little device where you can measure that angle, called an inclinometer. So you could actually do this to estimate heights of trees. The forester's highs are 5 feet off the ground. We'll use that in just a second. But assuming the tree makes a right angle with the ground, which my tree right outside my window doesn't, it's leaning. But if we assume it's a right angle with the ground, we've got enough information to find this part. We just need to add 5 at the end. because x is opposite of 75 degrees, and then we also have a side length that's adjacent to this angle. So opposite is what we need to be using. We have the adjacent to help us. Opposite of adjacent is a tangent function. The angle always goes inside. So the opposite is x, the adjacent is 60. So to get x by itself, I just need to know what tangent of 75 is, and then multiply 60 to both sides. So my tree should be, well, it's from eye level of this person, it's 223.92 feet off the ground, but then we have to add the extra 5 feet from where that inclinometer was aiming. So this tree is huge, it's 228.92 feet.